Let's try to understand the code. The first line is where we are trying to import the GPIO package for accessing the GPIO functionality of the RPi pins. Then I have imported the time package for giving the time delay, right? So time.sleep function works if you import this time package, right? Then in case you want to ignore the warnings, you have to write this statement gpio.set warnings false. All the warnings will be ignored. Then I'm using gpio.set mode gpio.board. So I'm using the physical pin numbering of Raspberry Pi. Then in the next statement, I'm using pin number 10 for using it as input, and you can see that pin number 10 is configured here as input pin with the pin pulled up, right? So when you have the second argument, that is pull underscore up underscore down, I am configuring it to be equal to gpio.pud underscore up, which means that the internal pull up of that particular pin has been enabled. The initial state of the pin will be logic high, right? So next statement is where I am configuring pin number 8 as output pin because I am going to use LED in this particular example, and it is connected to pin number 8 of Raspberry Pi. So we need to configure pin number 8 as output pin, right? So once done, I'm going to use while one because the code has to run in an infinite loop. So while one is written over here. After that, I'm just monitoring the state of pin number 10. So to monitor the state of pin number 10, it is gpio.input, and then you define the pin which you want to read. Here in this case, it is GPIO pin 10, and if the result is low, that means the push button is pressed because the initial state of the push button is logic high because of the enabling of the pull-up resistor, right? So when you press the push button, the state of the pin number 10 will go to logic low, and that is where you have to switch on the LED. So I will switch on the LED by writing the statement gpio.output 8, gpio.low. Why I'm writing gpio.low over here? Because in this case, the anode of the LED, as per the hardware that I have used, is connected to the positive supply, and the cathode is connected to the Raspberry Pi port pin. So in order to switch on the LED, I have to pass logic low onto the port pin to switch it on, right? So in this case, to switch on the LED, the logic which I need to supply to pin number 8 is logic low instead of logic high, right? This is because of the hardware configuration that I have used, where anode is connected to the positive supply and cathode is connected to the Raspberry Pi port pin. And the other condition is where you are trying to read the state of pin number 10 and it is logic high. That means switch is not pressed, and if switch is not pressed, the LED should blink. For blinking the LED, you have to make it on. So for making it to go to the on state, I'll write gpio.output 8, gpio.low. So again the same reason, to switch it on, it is at low level logic that it is happening because of the hardware. And then time.sleep 1, right? So this is going to give 1 second time delay. And then to switch it off, I am writing gpio.output 8, gpio.high, right? And then again a time.sleep 1 to give 1 second time delay for LED to remain in the off state, right? The only thing which is different over here is the logic which I am providing on pin number 8. In case your LED is connected in the reverse direction, your logic will be just reverse of what I have used, right? So this is it. 2 if loops are used and we are done with the logic as per the requirement of the assignment. So this is the code, guys. Now let us go towards the circuitry part and run the script over there and see whether it is working or not. This is the circuitry that I have designed. This is a push button array that I'm going to use for this experiment. I'm going to use only one push button, right? And the push button is connected to Raspberry Pi pin 10. When you see this LED array, out of these 8 LEDs, I'm going to use only a single LED, which is connected to pin number 8 of Raspberry Pi, right? The program is written as per the specification. That is, the LED will blink continuously with, let us say, the time interval of 1 second in between the high and low, and it's going to be a continuous blinking operation that will take place if the push button is not pressed. If I'm going to press the push button, then the LED will remain in the high state, right? That means it will remain in the on state till the time the push button is pressed. When I'm going to release it, it will come back and again start blinking, right? So this is what is going to happen in this particular circuitry. So this is my hardware setup that I have designed for this particular assignment. And now I will upload the script onto the Raspberry Pi board, and then we will test the functionality, right? So which means now I'll go back to my shell environment and I will run the script, and you will see the action on the hardware circuit, right? I will open the terminal. Once I open the terminal, I will go to the folder where I have saved my code. It is on desktop, and there is a folder on desktop with the name of Umesh. I will go inside that. I'll see the files by using ls command. The code is stored in the file which is named as Coursera4.py. So in order to run this file, I will write the command sudo space python space Coursera4.py. This is the name of the file which stores the code, right? When I enter this, we'll go now to the circuitry, because so now you can see that LED is blinking. It is continuously blinking with every 1 second time delay between on state and off state. And this is the push button which I have used with pin number 10 of Raspberry Pi. When I am going to press this button, the LED will go to the on state. It will stay in the on state for the time period for which I am going to press this particular push button, right? So now let us press this push button. So I have pressed this push button, and now you can see that LED is continuously on. It is not blinking. So as per the requirement, we have written the code that when the push button is going to be pressed, then LED will go to the on state, right? When I will release this particular push button, the LED will start blinking again, right? So I'm going to release the push button and you will see that your LED will start blinking again. So now I have released it. You can see that LED has started blinking again. If I do it again, I'll go back and I will press on this push button again. You can see that now LED is continuously on. It is no longer blinking. And when I release it, you can see that LED is blinking again, right? So I have used pin number 8 of Raspberry Pi for connecting to the LED. I have used GPIO pin 10 for connecting the push button. Initially the state of the push button is high. When I press the push button, the state of the pin goes to logic low, and that is what is read in the code. And according to the Python script, corresponding action is taken. That means when the push button is pressed, the pin will go to logic low and the LED will remain at on state, right? And if the switch is not pressed, the state of GPIO pin 10 will remain at logic high and your LED will be in the blinking state, right? So in the code we have just read the state of pin number 10 and accordingly designed the action, right? So this is it, guys, and this is assignment number 4, where we are supposed to control the LED with the help of push button. And I hope this is as per the requirement of the assignment. Thanks a lot for watching and keep learning with Coursera. Thank you.